Good evening, grade 12 learners. Welcome to the Science Less channel. Tonight, we're going to run through the last recap in preparation of tomorrow's exams for some of the provinces like Gauteng, Eastern Cape, Northern Cape, and so on. I know some of you guys, you're writing your maths later on, but also this live session will help you to do your revision and recap. So I'm just going to use here the preparatory examination that was written last year, September, for the Gauteng province. So paper 1, and you would realize or come to see now that when you write your exams now in June, for all your subjects really, is that basically you'll be tested on all the content that you should know for the syllabus. So this question paper will include everything that you need to know for mathematics paper 1, the section of paper 1. This is the reason why this thing is called preparatory examination or preliminary examination. Some people call it a trial. It's an examination before the main exam. It gives you a taste of how the main exam will be like in November when you write your finals. So it's a very important question paper or exam that you're writing tomorrow. It carries a lot of weight, it carries a lot of value. Now, obviously, the question paper will have the instructions. I always advise in terms of instructions that you read them before you go to the exam. Read these instructions, make sure you understand, ask questions and consult with your teacher as well in case you don't understand any of the instructions here. This allows you to go to the exam prepared, knowing what is expected of you in terms of instructions. And also, it gives you more time during the exam. You know, when you get to the exam room, they will give you a chance to read these instructions. You will have more time, and they'll also give you a chance to go through the questions before you start writing. And obviously, when you go through the question paper, you have to choose or decide which question you start with. Remember, you're allowed to start with any question. The only thing is that the question that you start with, you must write the whole of it and go to a new question. So instead of you reading these instructions in the exam room, don't read them there, read them now before you go there, because they don't change. They are always the same every year. Now, when you get to the exam, you don't read these things. You actually go through the questions, look at your questions, see which questions you start with, you know, the ones that are tricky, the ones that you think will be difficult for you. Then when they say begin, already you have enough time to have went through the question paper. So that is the advice that I'll give you for the instructions. I think by now you know these instructions, that you have been doing them from grade 10, they're straightforward. And you can go through them and prepare as I was saying. Now, let's get into action or the meat of the exam itself. The paper 1 of mathematics will always, especially now in September and your final examination November, consist of question 1, which is made up of algebra. The whole of question 1 will test algebra. Always, every day, it will test algebra. Now, in your algebra questions, your questions will range from solving the unknown variable. Usually we say solve for x, but really it could be any variable. They just like to use the variable x in these questions, but it could be any variable. It could be r, p, x, y, and so on. So these questions is either you solve for x by factorizing, you'll solve for x by using the quadratic formula, you'll solve for x by squaring both sides, you'll solve also x using inequalities, then you'll have simultaneous equations that you'll have to do and play around with. Sometimes they like to put the nature of roots, where you solve, a question that involves the nature of roots. Or you could have some tricky question, a silly question that will give you, that will challenge you and so on and so forth. And usually it doesn't take a lot of marks, 2 or 1 marks. And I always advise students that if you find such a question difficult, don't do it. Skip it and go spend time on questions that you can take marks. And it's okay if you finish the whole exam without writing that question, because usually it's just 2 marks. Anyway, you're not going to get the full 100% in most cases, but at least you can get a distinction if you are well prepared. So don't cry for 2 marks. Be strategic when you write your exams. I think that's what I want to advise on question 1. Now let's go into answering this question. So here we are given question 1, and we are told here in question 1.1 that we are given 2k is equals to x minus 5 multiplied by x minus k, right? So this is here question 1.1. We are given here 2k is the same as x minus 5, and you multiply this by x minus k. Now under 1.1.1, they say that if k, they say that determine, so the question starts from here to say determine k if x is equal to 2. So what are we saying here? We are saying under 1.1.1 that we must find the value of k if we know that x is equals to 2. Now this is just a matter of language. What we are saying here is that if we know that this x here is a 2, what will the k be? How can we find the k? So this means I'm going to substitute my x here in place of the variable x by a 2, and then simplify to find the k, the value of k, or solve to find the value of k. So now this means I'm going to take my original equation that says 2k is the same as x minus 5 times x minus k. Then now we substitute in here the 2 in terms of, in place of our x. So we're going to have 2 minus a 5, then we're going to have a 2 minus a k. You would come to notice that here I'm going to have a negative 3, because the combination of 2 minus 5 is a negative 3. Then here I'm going to have a 2 minus a k. Now this here says I can use the distributive property. I can multiply this and that to expand that part. So here I'm going to have a 2k is equals to negative 6 here. And here I'm going to have a plus 3k. And you know, this starts looking like something that we did in grade 9, where we have to group the like terms, yeah? So now this means I will take the 2k to this side so that I have 3k minus the 2k, and I'll take the negative 6 to this side so that I now have the 6 this side here. Now the combination of these like terms, as you can see, they will give me a k, because a 3 minus a 2 will just be a k, and then I'm having a 6 here. So this means that the value of k is indeed a 6. Now you can check this, you know, by taking this number here and substituting it here, and also putting it here, and also you put the 2, because we said x is 2. You must get that this 2 side have the same value. If you get I can already tell you that this side you're going to get a 12, because you know, 2 times a 6 is a 12. You must also get a 12 this side. Therefore, these 2 sides will then be equal, or both be 12. If you don't get a 12 this side, it means our answer here is wrong. So you can check that answer using a calculator in your own time. You should get 12 on both sides. Now, moving along to the next question, 1.1.2. It says here, determine the value of x. So now here they're swapping things around. You know, we're doing 1.1.2. They're swapping things around. They say find x. You know, in the first question we're looking for k. But here we're saying find x if we know that k is 2. So they take the value of 2 and give it to k now, and we want to find the value of x. Then this question, obviously, it will be a different approach. It will be a different question. It will be, you know, it will involve different mathematics to go through it. So we still have here 2k is equals to x minus 5, and we're having x minus k. And in this regard, we're having a 2 times a 2, because now we are actually substituting the 2 on the k instead of the x. So that now I'm going to have here the x as it is, because what I'm looking for, times the 5. And in this case, I'm going to have the x, and then we're going to have a minus 2. You'll notice that these questions, when they get here, they become different to each other, in that now here I have a binomial, whereas I have a binomial, I have the product of 2 binomials, whereas here I actually had a monomial and a binomial, right? So the expansion, or the way you will solve this, will be different. Now solving this would mean that I'm going to have a 4 this side, because a 2 times a 2 is a 4. And when we expand this, we all know the shortcut, I believe, at this stage, that we're going to say x times x, which is an x squared, and we are going to say x times negative 2, I'm going to get a negative 2x, and I'm going to say x times negative 5, and this will give me negative 5x, right? And these two, the combination of these two will really give me a negative 7. So that means here I'm going to have a negative 7x. Then we multiply the last time. I'm using a FOIL method here. Then we multiply the last terms there, which is negative 5 times negative 2. And indeed, that will give me a positive 10. I hope you are following and coming through here. I'll appreciate comments in the comment section if you have any questions, or maybe I'm running too fast and you are getting lost, because I don't want you to get lost. We have to move together. Now at this stage, this question becomes really simple, because now I want to put it in the standard form. That means I'm going to take here the 4 to this side, so that I'm going to have x squared minus 7x, and I'm going to have here, when I take the 4 to this side, it's going to be the 10 minus 4. So 10 minus 4, we all know that it's a 6. So I'm going to have a 6 is equals to 0. Now when you look at this, the standard form of a quadratic equation, so this would mean that we can factorize this. So now factorizing this, I'm going to write this into 2 brackets, and we're going to have an x here. And I can see here that my factors that will really work here is a 6 times 1, because 6 times 1, they actually give me a 6. So they give me the 6. 6 times a 1, they give me that 6 there. And also I can see that if I say that both of them are negative, so if I have a negative 6 and I'm adding it to negative 1, they will give me a negative 7, and this negative 7 is the one that's sitting here. Obviously, by experience, you should know that if you use 2 and a 3, they'll give you a 6, but 2 plus 3, they'll never give you a 7, or negative 2 and negative 3 will never give you negative 7. So the one that will work is a negative 6. Alternatively, really, you can use a calculator here, because you are allowed to use a calculator. But if you know how to do these things manually, you can really factorize them manually. Now you'll note that I've taken this negative 6 and negative 6, negative 6 and negative 1, and have put them in my brackets as the factors. Now at this stage, it then means that we can conclude to say x is equals to a 6 or x is equals to a 1, and those will be your roots or the solution to this problem if k is equals to a 2. Now we're going to move to question 1.2, where they say solve for x, and then they give us a bunch of questions. As I said, you will have different questions that require the use of a quadratic formula that requires you to square both sides, and also you do inequalities. So those are the 3 questions that we have. So basically in the first question, we actually use the method of factorizing, if you have been paying attention to that. Now the first question here that we have is 2.1. So in 2.1, we are doing 2.1.1, right? And we are given here 2x squared plus 3x is equals to 8x. 2x squared plus 3x is equals to 8x. Now, the first thing that one would want to do here is really to group all the terms in one side, so that we have them in a standard form. You always have to put the standard form, and they give you a mark actually for writing that standard form. Obviously, our standard form of a quadratic equation begins with the x squared, and its coefficient, which is 2x squared in this case, and it then comes with the bx, which in this case will be the negative 8x. In other words, I'm taking this and putting it this side, and the last term here would really be the constant, the c, which in this case is a 3, and then we are having a 0. Now what really I'm saying here is that this is sitting now in a standard form of a quadratic formula, ax squared. So this here is ax squared plus bx plus c. That's what I'm saying. Then we're saying it's equals to 0. Now there is one particular thing that I want to put your attention to. You would find that in your question papers, they'll always say that correct to 2 decimal places. Now if you know the quadratic formula, you would know that it has that square root in it, and that's where now the 2 decimal place thing will come through. So this already, they give you a hint here to say use the quadratic formula. Now, this would mean that I'll write my quadratic formula to say if I have a standard formula like this, a standard form that says this thing is equal to 0, I know that my x will be defined by negative b plus or minus the square root of b squared minus 4ac all over 2a. I believe this formula is there in your formula sheet. If you are not sure about it or you forgot it, relax and be peaceful. Don't worry. Go to your formula sheet, take this formula, use it in your question paper, then substitute your numbers. Now, if you look at this formula, it then says to us that we have to substitute the values of b, a and c and a here. So now if you check our b is a number that's sitting actually here is a negative 8 there. That means here I'm going to have a negative 8 now. Here we have to be really careful. We have a negative here, this is the negative. And our b, we're saying it's a negative 8 as well. Very, very important. I know these things, they seem simple when somebody is doing them, but when you write them, I know these are common mistakes. Even myself, I have an overwhelming experience in mathematics, but I still do those mistakes where I can sometimes not write this negative here, right? Very, very important. You must relax and pay attention when you're doing your question papers. I will have a plus or minus here, and my b here we're saying is a negative 8, and then it's squared here. Then we have a 4, we have a negative 4, and then we have the a here. Now our a is a 2 here, so that means I'm going to put a 2 here, and we multiply that by a c. Our c here is a constant, it's a 3, it's a positive 3, and we are going to have a 2 times the a, which we said is a 2. Now at this stage, this question becomes very, 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 very boring, because we are going to use our calculator, isn't it? So we are going to have here 8 plus 8 squared minus 4 times 2 times 3 all over 2 times a 2. And this gives me an answer of 3.58. So this would mean that our x is equals to a 3.58. Remember, they said we should round off our answer to 2 decimal places. So if you look at the number after the 8 there is a 1. So it means our 8 will remain as it is. So that is 2 decimal place, or we're going to say x is equals to. Now here you just go to your formula and change this part and only write the negative there. And we're getting here an answer of 0.42, because also, no, this will, yes, it will be a 2 there, because after the 4 we have a 1, then after the 1 we have the 8. That 8 will throw a 1 in the 1 there, then we're going to have a 2, so it's going to be 4, 2. And I hope you know how to round off. And this is as simple as it gets. This is as simple as it gets. Now, moving along, we are then now given a question here that says that we have 1.2.2. So 1.2.2, we are given here the root of 2x open bracket x plus 10. So the root of 2x plus 10 close bracket, and outside the square root we have a negative 10. So we have a negative 10 here, and we are saying that this is equals to x minus 12. This is the same as x minus 12. Now, this question, it looks really complicated, but it's a very easy question. However, there are many ways of doing it, or there are many ways in which you can start doing it. And those ways, they come with problems. There are some ways that you can take here that will make this question to be very long, very tedious, and it could turn out to be difficult. So I'm just going to share with you how you should do it. I know someone can want to start by squaring here and squaring here. If you take that route, you will get the answer. But chances are you'll do a lot of mistakes, because it's going to be very long, tedious, and it can become difficult. So sometimes try to narrow it or find a simpler path. So I will say here the best way to do this, because scoring something like this can be very difficult. I would rather take this and combine it with this one. So put it this side so that I have like terms here. So take the 10 so that I have a plus 10 here. then I'm only left with the square root. Then I can square that alone. It becomes a lot easier when it's like that. So that means I'm going to be left on the left hand side with a 2x plus 10, and I'm going to have x. So now here we're having a negative 12 plus a 10. That should give me a negative 2. So what am I saying? I'm saying if I take this one to this side, it's going to be a plus 10. Now negative 12 plus 10 should give you negative 2. You see now this question looks a bit simpler even to me. Now we can square both sides. Remember what you do on the left, you do on the right. Now when we square this side, the square root and the 2 would cancel. Remember that the square root is the same as 1 over 2. So it's like here we're having a 2x plus 10, 1 over 2, but we still have here the 2 because I'm going to square here. So the 2 and the 2 would cancel. Then I'm only going to be left with this number that is inside the square root. So here I'm going to have a 2x plus 10, but this side here I'm actually really going to have x minus 2 squared. I hope that makes sense. Now, how do we go about doing this? Well, this side here, we're going to use the distributive property by expanding this 2 times 2x and 2 times a 10, which means I'm going to have a 2x, then I'm going to have a 20 here. Now, when we come to this side, we're going to use a shortcut method where we're saying we square the x so that I'm having x squared. Then we take the 2, we multiply it with x, we multiply it with negative 2. So what am I saying? I'm saying here, to get the middle part, I'm going to say 2 times x times negative 2. What am I doing here? I'm saying this 2 here, we're multiplying it with this x, we're also multiplying it with that negative x. That will give you a middle part. I hope you know that shortcut. If you don't know it, then it's a method that you could learn here. So this would give me a negative 4x. That should give you a negative 4x. And then the last thing that you do to get the last term really is to square the negative 2 here. So you basically say negative 2 squared, and that should give you a 4, a positive 4. So that's a shortcut for squaring it. Otherwise, the other way of doing it really, which is going to be long, and you should avoid doing that because it's going to take a lot of your time, is that you can actually multiply this thing twice by itself and expand this. But I mean, you'll need 2 more steps there. I'm not sure if that's a good idea. So use a shortcut. So the shortcut says you square the x, then you multiply the 2, the x, and the negative 2. It will give you this part, and then you square the last term to get that last term. Now, at this stage, again, this looks more like what we did from grade 9, grade 8 to now. Because here now we are going to group the like terms, meaning I'm going to put all the terms on one side so that I have the standard form of a quadratic equation or quadratic formula, because I can see here that I have a square and I also have variables that are just having the coefficient of x. Now, what does this mean now? This means that I'm going to keep my x squared the way it is, and I'm going to have my negative 4x the way it is, and then I'm going to take this 2x to this side. So that means it will be a negative 2x when it goes to the other side. And following that, I'm also going to have here the plus 4, and I'm going to take here the positive 2 to this side so that it becomes a negative 20. So this becomes a negative 20. Now you'd notice that I've taken this and this to that side. So this means here I'm left with nothing. I'm left with 0, and I can write this side as a 0. Now at this stage, we can narrow this down really by just saying I'm going to have an x squared, and this one's here, they're going to give me negative 6, the combination of negative 4x and negative 2x. And if you look at your positive 4 minus 4, that should give me a negative 16 is equals to a 0. Now, this looks like a standard form of a quadratic equation, and we can factorize this, right? Already I can see factors in my head as I'm writing it down to say that if I try, half of 16, if you say 2 times 8, half of 16, 8 plus 8 should give you a 16. So, half of 16 would be 2 times 8. That gives you 16. And let's see, we need to have a negative 6 here. How can I combine these two? 8, so I'm having here an 8 and a 2. How can we get a negative 6 here? Well, if I make the 8 to be negative and the 2 to be positive, do you see that I'm going to have a negative 6? So this will be this negative 6 here. That means my factors here would be an x and an x, because obviously this gives me the x squared, but also one of the factors will be the positive 2 here. It's going to be sitting here, and the other factor will be negative 8, right? Because when I combine these two, I get this middle part here. When I multiply these two, I get the negative 16 here, right? And at this stage, we can then conclude to say, therefore, x is equals to negative 2, or x is equals to an 8. Now, a big reminder here when you do this question tomorrow, a very, very, very big reminder that you need to keep in mind and remember. When you get to this part of the question, you are not done. Take these answers and test them from the original equation that you started with here to see that, to check if the left-hand side is indeed equals to the right-hand side. You are checking here if the left-hand side is the same as the right-hand side. So what I mean by that is that you must take these numbers, substitute them here in place of x, and see if you get the same numbers both on the left and the right. The reason why we are doing this for this specific question is because we have a square root here, and a square root is not true for all real numbers. Some real numbers, for example, if we get a negative number here, this thing will be undefined. Just like when you are solving problems that are fractions. If you were to be given a problem that was a fraction like this, maybe, and then they're saying it's equals to 2, your answer, when you get your answer here, you must take it back and check, because we know that if you're dealing with fractions, some numbers here that we can put, if we get the 0 here at the bottom, it will be undefined. So you have to test your solutions or your roots, because some of the roots here might not necessarily be the roots or the solution to this problem. Now, to do that, it's a very simple thing. You don't even have to write it down. You just use your calculator. You'll come here and say, on the left-hand side, I have the root of 2 multiplied by, my first answer there is negative 2, isn't it? So I'm going to have negative 2 in place of x plus the 10, and then you close bracket, and obviously you must remember that we're having here a plus 10. So this means that on the left hand side I actually have 14. So this side here I have a 14. So this side, on the left hand side I have a 14, and let's see the right hand side. So on the right hand side, I'm having a negative 2 and a negative 12. And this gives me a negative 14. So here I'm having a negative 14. Now guys, let's look at these answers. If we use negative 2 to be the value of x here, we see that we're having a 14 and a negative 14. So this already tells me that the right hand side is not the same as the left hand side. So that means this here is not a solution, it's not the answer to this problem, it's not a solution, it's not a root. We must reject it. So x must not be equal to negative 2. Now we are going to test the 8 in the same way. So that now I'm going to pull the calculator again and say I have the root of 2 multiplied by 8 plus 10 plus the 10 again. Now this gives me a 16. So I get a 16 this side here. Can I use a different pen? I get a 16 this side here. Do I get a 16 if I say 8 minus a 12? So I get a negative 4. Okay, it could be that I'm doing something wrong here. It could be that I'm doing something wrong here. Let's double check. We said here we're having a 2 multiplied by 8. Oh, so here it's a positive. I was putting a negative. It's a positive 10, guys. I'm sorry about that. Plus a 10. Now I get a 16. So let's see. Let me quickly check something here. I get a 16 here. I put that positive again. I don't know why. So here we're having a negative 10 instead. All right. So remember, okay, just for me to go. This is a negative here. I was putting a positive. I don't know why I was doing that. So I'm having a negative 4 this side. So here, okay, let me adjust my eraser. So now here I'm having a negative 4. Now let's test the other side. We're having an 8 minus 12, and then it gives me a negative 4. So now what are we saying? We're saying if the x is a solution to this problem, if we put 8 here, our x is an 8 here, we get a 4 on the left hand side, we also get a 4 on the right hand side. And this is actually a true statement because negative 4 is the same as negative 4. So that means this is our solution. Now guys, it's important because if you leave your answer here, you'll get your full marks here. But if you say x is equals to 2 or x is equals to 8, you'll get the wrong answer. They'll give you 1 mark for only the 8. So it's important to restrict your answer because it will guarantee you the full marks. I hope that makes sense. Now we are going to move to the next question, which is question 1.2.3, where we are given 3x. 1.2.3, we are given 3x, and then we're having x minus 3. They say is less than 0. Well, this is a very simple question. I mean, even if you can check the result, the marks, there's 2 marks. I mean, it's a very, very, very simple question, this one, because already when you look at this question, it's simplified. There's nothing much further that you can do here. You cannot simplify this. I mean, if you want to multiply this here, it will give you problems. So already here I'm having factors, right? And when you're having factors, you're at the point where actually you can just solve the inequality. Now if you look at this, I'm going to break it into 2. If you look at 3x to the power 3, right, this power is always positive, right? It's always greater than 0. It's always positive. There's no way in which you can have 3 to the power x and it becomes negative. It will cause problems. It will be undefined, right? It will give you problems. So here we are saying this number is always positive, and it becomes positive for all the real numbers. If you take all the real numbers, it then becomes positive. So that's the first thing that you'll do. But also if you separate this second part of the inequality, it will then give you the fact that we're having negative 3 is less than 0. Remember, here we're saying it's less than 0. Now, if you combine them or you multiply them here, if you make them a composite function, you know, these things are like functions. If you look at it from that way, when you multiply them, it is true that they may be less than 0, meaning they may be negative. Remember, this means here that they are negative. They are negative. But if we separate them, like what I'm doing here is like that part where you're looking for critical values, right? Remember, when you look for critical values after factorizing, you actually separate the two. You'll find that when you look at x to the power 3 alone, it cannot be negative. It's always defined to be positive for all real numbers. But now if you look at the 3 minus x minus 3, it can be both negative or positive, but I'm just taking it the way it is from the question, because on the question they've given us to be less than 0. Now for this one, there's nothing much that we can do. It's a solution as it is. You can't really simplify anything here, but this one we can simplify by taking the 3 to the other side, so that we're having x is less than 3. So we are having here an x is less than 3 as your solution. And that's it. That's how you'll get your 2 marks. So they'll give you a mark for writing this or noticing that this type of exponent or exponential function. Remember, this is an exponential function anyway. It has an asymptote. That's why I'm saying that it's always positive for all the values of x, for all the domain, you know, all your domains here. This is a graph that will be moving like this. So there's an asymptote here. It cannot be negative because remember, this graph here cannot cut the asymptote. It will move as close as possible to the asymptote. It cannot cut it and come to this side. So this one is done as it is, and then you solving this, it will give you another mark there. I hope this makes sense, guys. I don't see comments or questions, so I believe that you are okay, you are following. I'm not moving too fast for you. Now we'll move to the next question, which is a simultaneous equation, because it says to us here, solve the following equations simultaneously. 1.3. Now here we are given 1.3, and the first equation there is root 3 multiplied by 9 to the power y. So we're having a root 3 to the power x, then we multiply this by y, 9 to the power y, and we are saying it's equals to 27. So this is the same as 27. Look, I can really write this as equation 1. I can say this is my equation 1 and move to the second part that says x. Okay, so the second one, we're having x plus 4y squared, and we are saying this is equals to a 6, I believe. Yeah, this is a 6. Now, how I'm going to do this is that I'll simplify this a little bit, because when I look at this one here, it's easy for me to take the 4 and 4y squared to this side, so that I'm having an equation that says x is equals to, and I can then take that as my equation 1. So I'm going to have here a 6 minus 4y squared, and I will say this is equation 2, right? Remember, when you take this to this side, it's going to be a negative. Now, the reason why I'm doing this is because now I have x is equals to, and I can substitute this x in equation 1. So here I'm going to say that substitute equation 2 into equation 1, so that now I will have here the root of 3. Remember, my 3 has an x at the top, so that means my x will now be 6 minus 4y squared. So here I'm going to have a 6 minus 4y squared. That is the x. And then here I'm still having a 9 to the power y, and this we are saying is equal to 27. So this is equals to 27. Now, the reason why I started with this is because I wanted everything to be in terms of y, so that I can be able to solve y. I happen to be very strong with exponents, to be strong with sets, so taking this root for me seemed to be easy. There are other ways in which you can solve this problem. So you'll see this becomes really easy. Now, at this stage, I know that this thing here, it's a square root. In other words, I will use the rule that says if you have the square root of a is the same as a to the power 1 over 2. Now, here, remember, we have an invisible 2. That's why we call it a square root. Square would mean is a 2 here. Now, if we write it in exponential form, meaning as a power, the 2 that's sitting here becomes my denominator, and the 1 that's sitting here becomes my numerator. So I'm going to do the same with this problem here. I'm going to have a 3, and I'm going to have the 2 coming at the bottom. Remember, the 2 that's here becomes here. And this one here, this part here, well, it's not a 1 in this case, but this part here becomes my numerator. So that means here I'm going to have a 6 minus 4y squared. And here now I'm going to change this to 3 to the power 3, which is going to be 3 to the power 2, not 3. 3 to the power 2 times y. Remember, we also have a rule that says that if you have a to the power r multiplied by n, this is the same as having a times nr. So you just multiply these two here. So that's what I've done here. Because what I've done here is that I've written the 9 as 3 to the power 2, but I have a y outside there. So these two, they give me 2y, and I have a 9 there. Now, this side, we are going to have 3 to the power 3. Remember, 3 to the power 3 gives you a 27. Now, I'm going to divide the 2 with a 6 and the 2 with a 4 there, so that I have a 3 to the power 6 over 2 is going to give me a 3, and 6 over 2 is going to give me a no, not 6, but 4 over 2 is going to give me a 2, and I'm still having here the y squared. I hope, guys, you are following. So just to help you, for you to see this, I'm saying I'm going to have a 2 here, 6 over 2 minus 4 over 2 y squared, and this should give you that, right? I'm just dividing by the LCM in each term there. Now from here I'm going to have the 2 to the power y is equals to 3 to the power 3, right? Now I'm going to use my laws of exponents here by saying I keep the base, so that I have a 3 minus 2y. I have a 3 minus 2y squared, and then I add the 2y. Remember, when you are multiplying two powers that have the same base, you keep the base, then you add the exponent. So I'm adding this to that. So I'm saying 3 2y squared plus the 2y, right? And now I'm going to have a 3 to the power 3. Now, when we are here, we can see that we're having two powers that are the same. You know, I'm having a power here that is the same to another power. And these powers have the same base. It means that for them to be equal, their exponents must be the same. So this part here must be equal to this part. And then if that's the case, these two powers will also be equal. In other words, we'll have the same numbers on the left and the right hand side. So here I'm going to conclude to say 3 minus 2y squared plus 2y must be equals to the 3. So this guy here must be equals to that guy. And at this stage, it becomes something wherein we can actually solve for y. It becomes really easy now to solve for y, because all that I'm going to do here is that I'm going to take all the terms this side to that side, so that the negative 2y squared will become positive when it goes to that side. So I'm going to have 2y squared, and the 2y will really be negative when it goes to that side. So I'm going to have a negative 2y. And this 3 will also be negative when it comes to this side. So I'm going to have a 3 minus a 3, which will really be a 0. And that means this side I'm left with a 0. I hope you guys are following or can at least see what I'm doing. Now at this stage, we then can take out the common factor of y, because we can see that y is common in these two terms in this binomial. So that means I'm going to have a y, and I'm going to have here a 2y, and here I'm going to have a 2, and this is equals to 0. Now look at this. If I say this multiplied by this, I get a 2y squared. Then if I say this multiplied by that, I get a negative 2y. Now at this stage, we're going to say y is equals to 0, or y is equals to positive 1. I see a positive 1. Should I write this step for you guys so that you can see how I got to this part? So here we are going to say 2y minus 2 is equals to 0. Then I take the negative 2 to the other side, so that I'm having a 2, and I'm dividing by 2 on both sides. I have a 1. So this goes to this side, it becomes positive. Then I divide here by 2, and a 2, it cancels. I'm left with 1. So my y becomes 0 and 1. But we are not done. Remember, we still are to find the value of x. So this means I'm going to substitute the values of y into equation which one? I think it will be easy for me to use this equation here. I'll say equation 2. Right, so we're going to substitute this in equation 2, so that we are now having x is equals to the 6 minus 4. So we had 4y squared. So our y, I'm going to start with the 0. Right, so I'm putting this in this equation here, the first solution of y. And this means here I'm only going to be left with a 6. Or we can have x is equals to 6 minus 4, but in this case we put 1 squared. So now we are putting 1 in that y squared. And so this would mean our x will indeed be equals to 6 minus a 4, which should give us a positive 2. And your answers therefore for x will be a 6 and a positive 2. Now, that's how you'll do this question. As I said, there are other ways in which you can do it. And also some ways, just like the question that we did with squaring both sides, can be long, tedious, and difficult. So, but also it depends on how strong you are. I happen to be strong with exponents and sets. That's why, I took this method that involved a lot of exponents. You can use other methods that you feel comfortable with. Now, guys, we also now have question 1.4. Now, in question 1.4, we are asked or required to determine here. They say, they give us here the problem to say the solutions of a quadratic equation are given by. Okay, so now let's break this down. When they say the solution of a quadratic equation are given by, they are actually saying that if you use a quadratic formula and you solve for x, you end up coming to this part, or you end up having something that looks like this. So this is a solution. You'll have two solutions here. If you use a plus, you'll have the first solution. If you use a negative, you'll have the other solution. So this becomes a typical quadratic equation where you have two solutions, you have two roots. By looking at this question already, I can see that it's a question that requires the understanding of the nature of roots, right? Now, with that specific problem where you are required to know the nature of roots, there's a couple of things that we need to know, but let's see what the question actually requires from us. So here they say that state the value or values of P for which this equation 1 will have two equal solutions, no real solutions, right? Before I do this question, maybe I can sort of give you pointers for those who don't know how to solve this type of equation that involves the nature of roots. Just for you to be ready if something like this come up. As I said, the last question here would be nature of roots or a question that's tricky or stuff like that, right? And as I said, they don't take a lot of marks. You see, this is like 2 marks here. So I was advising that, if you don't know what to do here, skip this question, do other questions, and come back to this later. If you don't have time to come back to it, it's fine, because, you can't waste time for 2 marks, because sometimes you'll waste 30 minutes here. 30 minutes is a lot of marks if you lose that in an exam. You need to capitalize here and do other important questions. But anyway, if you are given a quadratic equation that has the form ax squared plus bx plus c is equals to 0. If you want to find the solutions of this equation, you will use the quadratic formula that says you'll have minus b plus or minus the square root of b squared minus 4ac all over 2a. So this becomes a solution to this problem, right? To this equation that we have here, the standard form that we have here. Or it becomes roots, sometimes we call them. That's another way that they call it. So roots and solutions, what they mean is that they are answers to this solution. In other words, to this equation, they make this equation to be true. In other words, if I put the values of x that I get here, I should get that the left-hand side and the right-hand side are exactly the same value. So if I solve this thing and I get a number, that number, when I put it here, I must get a 0 here, because you're saying this side is a 0. That's all that it means. If I don't get that number, it means that value is not the solution, it's not the root to this answer. But there's something that we call a discriminant to this problem. So a discriminant is really defined using the delta, the small triangle, which in Greek we call delta. And the discriminant is given by b squared minus 4ac. So the discriminant, if you look at it, is this part here. So what I'm saying is that this formula will change now to something like b plus or minus the root of the discriminant all over 2, because I'm saying the discriminant here is this part. What does the discriminant do, or why do we need to do the discriminant? The discriminant assists us to know the type of solutions, the type of answers that we will get when we solve quadratic equations. So, as you would know, sometimes you can get answers that are the same, answers that are the same. You can get the values of x that are the same. Have you solved a quadratic equation like this one, and you find that your values of x, they become 2 or 2. So we say these values are equal, they are equal solutions. the discriminant is the one that will be able to tell us that to be the case. So for example, if our discriminant is equals to 0, then we will get answers that are equal. So we'll get answers that are equal. We'll get two equal roots, two equal solutions, right? But now if our discriminant is less than 0, right, then no, there are no real solutions. We don't have a solution. Can you see here that if our discriminant here becomes less than 0, meaning if it becomes negative, then this part here, it will make the whole thing to be undefined, because we know the square root of a negative is undefined, so the whole thing will be undefined. So that means the value of x, our solution, will be undefined. There will be no real solutions. The other option that we have is that the discriminant can actually be greater than 0. It can be positive. Remember here it's negative. Here it can be positive. The discriminant can be positive. When it's positive, we have two options. One option is that we'll get two unequal solutions. We'll get two unequal solutions. This is a typical situation where your values of x will be a 2 and the other one will be a 5. You see, these are like unequal solutions. But now if you happen to have a perfect square, meaning this part here happens to be a perfect square, a perfect number. So these are numbers such as your 2, 4, 6. If this part gives you those numbers, we then get two equal we get two unequal irrational numbers, right? They become two unequal irrational numbers. So in our problem, we are going to use the first one, 4.1.1. We are going to use this part here where we're saying the discriminant should be equal to 0, because when the discriminant is equal to 0, we get two equal solutions, two equal roots. I hope this sort of summary, a quick summary here of nature of roots makes sense. So what I mean here is that if we go to 4, just to answer the question now, if we go to 4.1 and we are looking at 1.4.1, remember we are given here that our answer, our solution to the quadratic equation is really defined as minus 2 plus or minus the root of 2p plus 5 all over a7. Now what I said is that this part here in the bracket is what we call the discriminant. So I'm going to write this like this here, delta, a delta. That means discriminant is the discriminant is the one that we're going to use to find the type of solutions that we have, right? So just to remove this numbering here. Now I can answer this question now to say, if they say we must find two equal roots will occur when the discriminant is equal to 0. So I'm going to argue here to say for equal solutions, if I'm looking for equal solutions, my discriminant should be equal to 0. If this part here is 0, then I'll get two numbers that are the same. That's what we are saying here. Our value of x will be two numbers that are the same, as the question is requesting. But now we are saying here that the discriminant is the same as this number. So that means here I'm going to substitute the discriminant as 2p plus 5 is equal to 0. And I'm going to then look for the value of p, which is simply going to be negative 5 over a 2. Because remember, I'm taking this to this side, it becomes a negative. I divide by the 2, I get a negative 2 over 5. So, what I'm saying is that if here we have negative 5 over 2, this whole thing will become 0. And when it becomes 0, you'll get two numbers that are the same. So our answer will be negative 2 over 7. Twice, it will occur twice. Right? I hope, guys, this makes sense. I know that the nature of roots can be confusing sometimes, so I should see comments there, or maybe questions so that I can address them before I move on or go far. Now, if you look at 1.4.2, 1.4.2, they want us to find the values of P for which this equation will have no real roots, if it doesn't have real roots. Now, when they say it doesn't have real roots, what they mean is that this part here, if it becomes undefined, if this part here is negative, then it means the whole thing here will be undefined. We won't have real roots, right? We won't have solutions to this problem. So that happens when the delta or the discriminant is less than 0, is negative, right? So that means here I will say, if we want solutions for no real solutions, if you're looking at a situation where there are no real solutions, our discriminant should be negative. If that part here, if this part here that has the square root becomes negative, the whole thing will be undefined, and it means we don't have real solutions. We don't have answer. It will be undefined. You know, when you press on a calculator, it will be undefined, and that means we don't have a solution to this. But we said here that the discriminant is actually defined by 2p plus 5, then we're saying it's less than 0. And this becomes a simple linear inequality, where we're really going to then say p is less than negative 5 over 2. Because again, I'm going to take this to this side, it becomes negative 5, I divide by the 2, then I have p is less than negative 5 over 2. So what we are saying here is that if the value of p is any number less than negative 5 over 2, if you put any number here less than negative 5 over 2, then this whole thing will be, this part will be undefined, making the whole thing to be undefined, and therefore it means we don't have real solutions or real roots to this problem. Now, I hope that explanation made sense to you guys and you are still with me. Now, that is question 1, and you know, that's what you will get as your algebra problems. I will stop here a bit for a 5 minutes break, just so we stretch, drink some water, and then we will continue doing question 2, which looks at sequencing and series. So we'll be back here after 5 minutes. Have some water and stretch a little bit.